Okay, another separable differential equation. Now, this one looks a little bit different. You have a dx over dy. It doesn't matter. X and y are letters. I mean, there's this classical convention of y as a function of x, but it's kind of arbitrary. The main reason we have x's and y's because Rene Descartes asked the French newspaper which letters they use the least. Anyway, so what I'm going to do is I'm going to take the x squared and I'm going to move it over to this side and I'm going to divide by y and move the dy over to the other side. Okay, so this thing would turn into x squared ln of x dx, which is going to equal, this is going to turn into y plus 1 squared divided by y dy. Get away. Okay. I'm going to, instead of writing the integral on that stuff, I'm going to write the integral on the next stuff because I need to do a little bit of algebra to this. Okay. So this would turn into the integral of x squared natural log of x dx, which is going to equal the integral of y squared plus 2y plus 1 divided by y. Let's do a little bit of cleaning up on our algebra. Okay. So that would turn into the integral of x squared ln of x dx, which will turn into the integral y squared divided by y would be y. 2y divided by y would be 2, and then plus 1 divided by y, dy. Hence the way. I'm going to run out of room if I don't try to write a little bit smaller. So now we've gotten to the point where we can at least start the integration on this thing. Okay. Now, the integral of y2 of 1 over y, those aren't bad. But this guy right here, that's going to present a problem. Okay. It's going to represent a problem that's going to require one of our techniques of integration. Okay. And one of one of the big things that you are going to need to know for this class is integration by parts. Okay. Now, this isn't a decay of the polynomial integral. This is, I want to integrate anything besides the natural log so that I can differentiate the natural log. Okay. So what I'm going to do is I'm going to integrate the x squared. So if I integrate x squared, the integral of x squared is x cubed divided by 3. Okay. And then multiplied by the natural log of x. And then minus the integral. Okay, this becomes x cubed divided by 3, when the derivative of the natural log of x is 1 divided by x. This is dx. Okay. And I can go ahead and integrate the other side. So this turns into y squared divided by 2 plus 2y plus the natural log of y plus c. Well, screen is it. Too much better. Okay. Now x cubed divided by x, this is going to turn into x cubed divided by 3 multiplied by the natural log of x. Now minus the integral of x squared divided by 3 with respect to x, which is going to equal y squared divided by 2 plus 2y plus the natural log of y plus C. You're just making noise. I'm recording. Okay, so all right, last step of this problem. We're going to integrate x squared. And so x squared is going to become x cubed divided by 3 again. But we already got a 3 on bottom. So this becomes x cubed divided by 3 multiplied by the natural log of x minus this becomes x cubed divided by 9, which is going to equal y squared divided by 2 plus 2y plus the natural log of y plus c. Okay, and that is actually going to be the solution to our problem. And we're going to call this implicit. Okay, and the reason that I'm calling this as an implicit solution is, well, it was dx over dy at the beginning, but frankly, there's no way for us to solve for x or y individually. And so this equation is too complicated to solve for either one of the variables. So we just say, this is going to be an implicit solution. This is going to be, you know, in calculus, we would describe this as something that is a relation, not a function. So there's no way to get an actual y as a function of x out of this. So we call it an implicit solution. There's nothing wrong with implicit solutions. And as a matter of fact, on your test, unless it specifically says to find an explicit solution, if you get down to an implicit solution, I have no problem with that.